In our everyday world, space and time are seen as two unrelated entities. But in modern physics, they're combined into a single and smooth continuum called spacetime. Now, if you're wondering why that is, you come to the right video. Or I've come to the right audience. You see, there's a bit of, a lot of relativity involved. In order for us to show one's journey through space and time and how it seems relative to others, we need to draw a space-time diagram on which the x-axis represents space and the y-axis represents time. The lines we draw on this diagram are called word lines. Now, let's apply this to our world. If I don't move as time passes, then my word line and the word lines of the two trees I stand in between will all be vertical. But if I do walk by the trees, my word line will be tilted a bit. In that case, the diagram will be in the tree's perspective. If I want to shift it so that it shows my perspective, I need to make my word line vertical again, because that is when things move with respect to me. The most obvious solution is to tilt the diagram itself and put some new axes. This is called a Galilean transformation. It seems to work pretty nicely, but only within the realm of classical mechanics, where objects are pretty big compared to elementary particles like electrons, and much, much slower than the speed of light. So let's see what happens if we involve light. But first, let's say that our spacetime diagram measures 299,792,458 meters with each tick mark on the x-axis and 1 second with each tick mark on the y-axis. Because then, if we draw the word line of light, it will be a 45-degree line. This is important because according to experimental evidence, the speed of light doesn't change even when we change our perspective. Like, ever. Back to me. Say I give my flashlight to my imaginary friend who stands where I walk towards. This spacetime diagram shows her perspective. Here, if we use Galilean transformation to get to my perspective, then we will have changed the angle of light's word line, hence the speed. So what do we do now? Luckily, in 1900s, Albert Einstein had a solution to use Lorentz transformation, for which we'll need to consider space and time to be the parts of the same continuum, spacetime, the fabric of our universe. Then we can stretch that fabric along the word line of light and squash it by the same amount at a right angle to the word line. And voila, we've got my perspective. So now you know why we needed spacetime. Even space and time are at their best when they're together.